Thanks for coming to the August 30th high availability call. I'm going to turn off my camera and hand it over to the Pensando AMD team in just a second here. And I guess we can get started.
You guys able to see what I'm sharing?
Yeah.
Okay. So what we're presenting is a proposal for the HA thing based on the implementation that we have.
Yeah.
So we have. I'll just give a quick overview on what is to come. So all of us are, we know what to expect. What's coming up next. So I think we have some design goals. We have a functional description that includes how the network topology looks and what we have designed it for. And we also kind of go through what are the IPs that what do we expect from the network, right? In terms of the WIP, in terms of the loopbacks that we expect. And then there is how the active works. Then we have a small section about the heartbeat. And then we get into the state synchronization, both the bulk sync and data path synchronization of how it works. I think Balki had presented some of this already. I think we have kind of taken it and tried to put in more details and abstract it out, put some more details in there. How at a high level, how the sync message looks. And then wherever we can, we have kind of put what are the challenges that we see or things that gotchas that we saw when we were implementing, right? Whenever those gotchas are not to implementation specific and more generic, we have kind of tried to bring those out in each of these sections. And then we go through the state machine itself, the HS state machine, some explanation of the states. And after that, I think to illustrate what we mean by, there are a lot of messages that are going across in each of the states, etc. So there are two sections for these messages. This is I think the messages themselves are illustrative to show what we mean by what should go in these messages. There's one set of PSI definitions, right? This is the interaction between the sonic layer and the SDK and anything, the TPU, hardware, software underneath that. And finally, we have some control plane messages. These are the messages that are going, that we are proposing go between the two sonic instances, right? And then there are some message flows, right? So we have taken some important procedures like the node pairing and bulk sync and how that is work. What are the message flow between them? So this uses all the messages that we have defined before, and we try to say how the flow would look. Then there is one for unplanned switchover, and then there's a planned switchover. So that is the general structure of the document and what we're trying to propose here. Any questions here?
No questions, but that's amazing work for just a couple of weeks. It's great.
Right.
So these are getting from the get-go from the design goals. This is what Balki presented to. So here we are saying, so we are on switchover. The intent is that all connection setup before the switchover have to reliably work whenever there is a switchover, either planned or unplanned, right? We try to keep the drops. If there was a flow that was allowed before and it was functioning, we try to never drop that flow or create a disruption in that flow. For planned switchover, the design is attempts to get a zero downtime for planned switchovers and less than 2-second downtime for unplanned switchovers. Also, because of flow replication, we don't want any data packets to be dropped. That is a goal that we try to achieve. And of course, the high CPS rates that are the requirement here. We want to keep up that CPS rate and sync up the flows and keep that HA at the same high CPS rate. And I think we have talked about this quite a bit. We only try to keep one goal is to actually not over use the PPS path and keep the data traffic to the as minimum as possible, right? And sync only the required packets. where at a very high level, this is I think just to clear out the terminology in terms of how we are using terms below. So there is a Sonic stack above. This is all the SyncD, SWS, everything else, right? GNMI, everything else. Then there's the Dash SDK. This is the vendor implementation, the SDK layer. Then there's the DPU. The DPU could be hardware or could be any associated software components. For example, we might have some software components for the CPS path and things like that. So the DPU is one blob which covers both the hardware and the software components, where everything that is under the Dash SDK is the DPU. Then the network topology itself, I think this is pretty known. I'll get to this very briefly. So what we're saying is there are two links coming from each DPU going to the TOR, right? And it will be kind of spread across the two TORs for redundancies. And apart from that, we have, because we don't want the HA to be tied to any of the physical links, we have a loopback IP, which is apart from these two link IPs, which we call as the control plane IP, right? The control network IP. And then there are two data path whips that are shared between the DPUs. And both of them advertise, and they kind of own. The first one, the control network IP, is owned by each, it's unique to each DPU. And the reason we need the control plane IP is so that if any one of the links go down, we don't kind of bring down HA. There is still a identity that can be reached as long as there is some connectivity, right? So the control plane IP, or the CNIP as we use it underneath, this is used for all the control plane traffic. For example, all the synchronization, both bulk and data path sync, any heartbeat messages that go between the two, or any control messages in the proposal to move the states for the state machine from one state to the other. So everything that we want for the control plane, or anything that DPU to DPU traffic is originated using the CNIP and terminated using the CNIP. Then we have two data path whips, or whips in short. These two whips are owned by the pair, right? The way they are owned is, the way they are set up is one whip, each whip has a primary and a secondary node, and it is striped across. So there is, at any in steady state, when both the DPUs are active, one of the whips will be primary and the other will be secondary on one DPU, and it will be a mirror image on the other side, right? So the other whip will be primary and secondary. The idea is if one of the DPU fails, or if there is a switchover, then the surviving DPU kind of becomes primary for both whips, right? And then continues to service all traffic for the. So this is how, because of this, we are able to do active-active. So each ENI is assigned to a whip, right? So so this is what we call as ENI-based active-active. And the data paths for on both the DPUs are always forwarding and always active in terms of the forwarding path, because they're active for either one of the whips, at least one of the whips that. Then there is a data path heartbeat. There is a heartbeat message that is periodically sent between the two DPUs. There is a configurable interval, and there is how many loss can we tolerate, right? If there are X number of losses between the heartbeat, then we declare that the peer has been lost. This is configurable, and since it can be as aggressive as it can get, right? It do it in a few hundred milliseconds or tens of milliseconds if you want. Any questions so far?
Hey, Sanjay, yeah, I have a question. So this data plane whips, right? Like, so I think like theoretically, each DPU can, I mean, like it can obviously handle multiple ENIs, and this ENIs can be replicated across different set of DPU pairs, right? And
Correct.
now, yeah, like, so if we have this DP pairs, do you expect that each DPU have like multiple of these whips, or we'll just pair with just one other DPU and they will just yeah, like provide HA for the CNIs?
Yeah, so I think currently for each pair, there will be two whips is what we expect.
Sure. Yeah, like I
Well-
think like if we have to shard the ENIs across DPUs, right, then we need multiple of those whips, right?
So each ENI is always associated to one whip. I think probably I'm not getting the question fully. So I'll just explain. So each ENI is associated to one whip, and that whip is associated to a pair of DPUs.
I think what he's asking is the way we do that with ECMP is that's done at the VM side. So the ENI could appear on multiple DPUs, but they don't know about each other. All they know is those multiple DPUs have identical policies and different connections land on each, but that's done by spreading it through some ECMP algorithm at the VM itself. So the DPUs actually don't know that there's another DPU handling some of the connections for that ENI that have no idea. So from their perspective, it's just, 2 bips. They don't know about the other cards. We haven't implemented that yet, but that is the plan. So we will have identical ENIs and policy on multiple cards. But again, those DPUs don't know about each other, and they don't need to. They only need to protect the connections that land on their DPU.
I believe the question was perhaps the sharing of the WIP across multiple ENIs, right? The way I understood it, because what happens is that, if you have a primary and a secondary WIPs, are they primary and secondary per ENI? Because if you think about it, right, any DPU could be an active for some ENIs, but standby for others, and vice versa, right? So in that sense, are we really controlling at the WIP level, or are we controlling at at some other level to say that okay, you could have a different role, but depending upon which ENI we are talking about.
Is your question that we
yeah,
would do a failover per ENI? Because we don't do failovers per ENI. The whole DPU fails over. All of the ENIs.
Correct. But what happens is that your DPU is not, the entire DPU is not really acting as a standby for all the ENIs that it is serving. It could be half and half, right? You can say that half of the ENIs are broadly acting, right? Right.
Correct.
So then the question here is that how are we really distributing? I mean, is there only 2 WIPs that are advertised by a single DPU for all the ENIs that it is supporting, or is it some other scheme of how the WIPs are basically configured?
Yeah. I think the WIP is per card, right? So because you cannot really advertise too many WIPs, cause some other issues for the underlay network. But I think this part, I would say it's not directly relevant to the HA part, because different setup, different setup may have a different how they advertise VIP, right? So I think that could be different. That I don't think it's strictly tied to the HA part.
Yeah, thanks, Gohan. Yeah, I think, yeah, agreed on that. Like, I was just wondering how many whips each DPU will advertise. So I guess like it's just 2. So that
Currently,
implicitly,
it's 2.
right.
Currently,
So
it's 2. Yeah.
that implicitly means it will get paired to just another DPU, right? Like we will not be pairing with multiple other DPUs. Is my understanding right?
Right. So if your question is, I think it's not, it won't be for VIP1, we are pairing with DPU1, and for VIP2, we are pairing with DPU3. You see what I'm saying? It's not like a chain. It's a pairing between the two. Does that answer?
So
Surabh?
yes. Like, so I think like each DPU will just pair with another DPU, and they will just have one set of.
They share 2 dips. They share
Yes.
2 dips there between them.
Yeah. In this
clarifying
mode,
question.
True.
A quick clarifying question is that the WIP is per DPU. Per DPU, the active flows that it's managing that have landed on that DPU, right? The active flows, right? Meaning it could
So
also be.
I think maybe this is a little bit confusing, right? So we should focus on the the HA part, because the setup I think it could be different. Maybe we should simplify the doc a little bit and focus on HA part. Saying that for the HA we should focus on per ENI based HA. So every ENI we should be able to do the HA, right? So that is a requirement for the HA. Right, so how do you set up those VIPs? I think that's kind of it seems like people have more questions on that front. But the requirement for the HA is be able to do the per ENI based HA.
It's not per ENI, Gohan, in that one ENI can't be backed up by a different card, and another ENI backed up by a third card, another ENI backed up by a fourth card. They're all backed up. They're all backed up by the same card.
Yeah, that's what I mean. The ENI base, right? So, per ENI you can have different backup, and you really want to do the HA at the ENI level, right? So, because the ENI signed, the active and backup could be different cards, right? So
I have a question. Let's say in a configuration, you have a simple configuration of 2 DPUs, and you have 64 ENIs. Are you going to have all 64 ENI is going to be active on one DPU, and then another DPU basically acting as a standby for those all 64, or are you going to really split them onto both the DPUs, saying that okay, 32 are active on one and 32 are active on other ones? How you?
Yeah, it'll be 32 are associated to VIP1, 32 are associated to VIP2.
Exactly.
VIP1 is active on DPU1, VIP2 is active on DPU2.
This is exactly my point. And now what happens is that if that were to be the case, right, and that's how I understood it as well, if that were to be the case, right, then your VIP advertisements are different for different ENI, right? So in one case, one DPU is advertising the secondary VIP as a primary, or and vice versa, so that they know that okay, this is how it is working. Isn't it the case, right?
That is the case. So it is mirrored. So there is we haven't gone too much into detail into the actual advertisement on how we are controlling the BGP advertisements or whatever the protocol advertisements. But we can. So there is the way it would be is it will be mirrored. So the way the standby or the secondary announces 2 VIPs. One VIP will have a good metric. The second VIP will have a less desirable metric, and it will be the mirror image on the other side, on the other VIP.
Right. And it will be different for those 32 versus the other 32 who you're advertising, so that things land correctly. If you are only using 2 VIPs. Right.
Yeah.
Right.
The only thing
I think that actually explains the entire thing. I'm sure. I believe the Suresh N who asked the earlier question. So that actually essentially answers the question that hey, there are only 2 VIPs. It's just that you are controlling the advertisement to whom you're advertising. That becomes the primary for that one and the secondary for the other one. So then that's how you spread the load evenly. To say that okay, both can be active DPUs from the global perspective. But from the local perspective, one is acting as an active versus the standby, right?
Yeah.
Okay. Yeah, that explains. Thank you.
Yeah, I think like Govan was saying, we haven't this document we haven't focusing too much on the network control plane advertisements and what we do. We could have another session, but this more focuses more on the HA portion. It's what's happening. But yeah, you summarized it correctly.
Thank you. Yeah.
Good. Then if there is nothing more, we can go to the synchronization itself. So the state synchronization here, I think this uses, as we said before, this uses the SANIP IP, and this originates and this thing. So there are two pieces for the state synchronization. There's a bulk sync, and then there is the data path sync, which is the flow by flow sync, and then there is a bulk sync. Right. Effectively, I think there are two channels or two pipes that we have to communicate between the two. One is the control plane channel, and one is the DP sync channel. As the name indicates, the control plane channel is used for all the control plane messages between the two DPUs. DPUs, I mean the whole units. And then there is a data path sync channel, which connects the two DPUs, the actual forwarding this thing to synchronize the flow by flow. Flow by flow sync happens there, right? So the control plane channel in this proposal, we are, it's represented as, it's a bidirectional gRPC stream that goes between the two instances. And this stream can carry messages between the SONiC stacks, right? This might be for controlling the state machine or messages to that effect. Or it could be messages that are going, the DPU to DPU. If there are some messages that need to go, it gets relayed through the SONiC stack via the control plane channel. But effectively, it is a streaming channel. I think what the streaming gives us, it gives us more efficiency, and it gives us, there are no, if it was a unary kind of a thing, if it was a request response kind of a thing, it becomes slower. So the stream gives us some advantage there. And the DP sync channel is also another stream between the two DPUs, which carries the flow by flow sync messages between them. Right. We will get to, I think, when we go to the later sections for the message definitions, we will get to see what this control plane channel messages are, what are the kinds of messages that are there. And that should give a better idea on. Then any questions here on the?
Yeah, what is this purple line and the yellowish line?
Yeah, so this might be there are messages that are there might be messages on the control plane channel which are originated by the SONiC stack itself. That is the orange line. There is a purple line where the DPU, if there is some control plane information if there is some signaling that needs to go between the DPUs too, there could be, I think the DPU also could, via this SI, there might be notifications that come up, get relayed across this control plane channel and to the other side. So these are essentially control plane messages, but not between the DPU, but not the data path sync messages. Everything else goes via the same control plane channel.
Okay, got it.
Yeah.
Are you cover question, Sanjay? Are you cover that in more detail in subsequent section?
Yes, I will. There is a bit. Yeah, there's
okay,
a little
got
more
it.
detail.
So we'll wait for that. Thanks.
Cool. Yeah. Okay, so the bulk sync itself is when we need it is we have one DPU which boots up, and then when the DPU comes up, the lifetime, if you see that there is no other peer, we wait for a timeout. and then it would go into what we call as the primary standalone mode, right? So it is configured as it is working as primary, but it is not syncing anywhere. It is in standalone, right? So this would be for both the WIPs. It would go to primary standalone mode, and it would because there is no peer, it would kind of like we were saying, it would advertise the WIPs, attract all the traffic to itself and to the DPU, and then forward those traffic, make connection flow entries, and forward as normal, right? And it would build up some flow state. Let's say at some later point in time, the second DPU comes online. When the peer DPU comes online, the two would detect each other. The two DPUs would detect each other. Now, the new DPU that is coming up would need to sync up all the state from all the accumulated state from the primary, right? Whatever was in the primary standalone mode. So this is when we do the bulk sync, right? At this point in time, we use the control plane channel that we have. And then on this channel, we sync all the flow, all the accumulated state, right? So this is a bidirectional stream. And in this stream, the key difference here, I think why it's been a stream is we want to, from our experience, what we have discovered is the indiscriminately, if you just dump all the state to the other side, to the other DPU, it can start affecting sometimes, one of the WIPs might have come online. It starts affecting the CPS path of whatever is already being serviced, right? So I think what the bidirectional stream affords us is we can actually stream it in a way so that we can more efficiently populate the other side. So there could be in the stream, you could go through some portion of the, we are following the same perfect sync mechanism, right? So we have marked in this thing, we're taking a snapshot in this mechanism. We take a snapshot of what is in the current flow table, and we mark everything else that all the new connections that come up, they are marked as some color, right? So we sync everything like in the perfect sync mechanism, we sync everything in that bulk sync snapshot to the peer, right? And when we are syncing this, we might, this is usually the number of flows that we have could be in millions, and it takes some time before it takes some quite a bit of time before we are able to sync. I think last time we were talking about tens of seconds, 60 seconds to 80 seconds to sync all the flows to the other side. So while this is happening, we want to sync this in the most efficient way because it's a scale thing. So we stream all the flow sync messages. So what we would require, what the DPU can, I think each implementation on each side, the DPU might have efficient ways of selecting the flows that it needs to sync. For example, it could be, we could have a slide, control plane, a CPS path slice, which we want to populate it at once, right, in one batch, and populate the next slice in the next batch, etc. So the stream affords that, and the DPU can choose what streams it will, what flows it will sync in what order, and there could be some back pressure or some more signaling that can come from the other side to control this bulk sync. Right. So that is how we choose this thing. I mean, how the bulk sync happens. There's a little more detail in the message flow when we get to the bulk sync, but effectively, this is the bulk sync mechanism. So I think the key thing is it's not like there is a list of all the flows and we copy over all the flows in one go to the other side. Rather, it is more of a stream where the DPU can choose which set of flows to pull from the primary so that it can be more efficient when we sync up from the other side.
But you do color them, right? As you mentioned in the previous, right?
Correct.
So you color them, and then that's how. But I have a quick question on just the IP addresses you mentioned before, right? There's a control plane IP address there is that what we basically use as a path for both data plane or data path sync as well as for the control plane channel?
Yes. So the CNIP address that we were saying, that, yeah. So that is the identity for each of the, so the VIPs, because they're shared, we can't use them for any of the DPU to DPU.
Right.
I mean, yeah, node to node communications.
And there is, of course, that, you know, it all goes through whatever the fabric we have through the TOR. And essentially we are using the provider IP address space, correct?
Correct. The underlay, the provider.
Underlay.
Provider.
So in other words, all the data that is, all the packets that we are syncing, they're essentially encapsulated in some ways so that, you know, they are just essentially are traveling in some sort of encapsulation, which is I guess, you know, not overlapping to the provider space. Correct.
Correct. So yeah, so they're all, I think the outer, if you look at the outer SIP and DIP, it would be the CNIP to CNIP. So the provider provider just routes them here. It's not in the tenant space. Yeah.
Okay, thanks.
So essentially, I think one thing to note here is during the bulk sync, we are not actually carrying any user traffic itself, right? So this is our own format that we have below. I think that's there in the defined messages below. So this is our own format that we are sending. This is actually essentially a gRPC channel between the two. But what you were saying about encapsulation, I think makes more sense in the DP sync channel, because the way we are doing incremental sync, we'll talk a little bit in a couple of sections below. We would it would actually carry the actual user traffic, so we have to put an encap on top, right, and carry the user traffic to those.
Yes. So this part, I think I get it, but I don't quite understand the comments about the bulk sync. I understand the back pressure things, right? But I don't understand like the selecting part, right? So, you know, what is the criteria you're selecting the flows to sync? I think, you know, in the initial bulk sync, isn't that on one side, it's, you know, it has all the data, on the other side, it doesn't have the, you know, zero flows. So you could just dump all the flows from one side to the other side. So what is this, you know, selecting part? I don't quite understand that part.
That even the walk-to, we have multiple of. I think I'm just taking, when I say from Pensando MD, I think it is our implementation, but we expect it might be very similar in other implementations too. So there are multiple of these control plane threads that we have. So the way we want to select and push them to the other side might we could choose from the other side. So this is effectively the purple line that is there going. Each of them, it could be we want to for one thread we want to get n number of flows for one of the CPS threads, and then we also, because it's all the buffers are also limited. So from one thread we don't want to block any of the threads in trying to populate the buffer to push to the other side. So there is some back pressure there too, right? On how much we can, I think the whole thing is optimized to the, so that we can actually get it in the most efficient way. So you can say how many flows you can put, even the producer can also choose how many flows it can put onto the buffer, so there is no blocking anywhere. The second thing is, as we are, for each of these threads, we should also note that I think I have some of that we noted down in the interaction between the two. As we are picking from these flows, there is also the same flow table is being acted upon by current activity from the network, right? So there could be other traffic which is changing the state of the flow, like terminating the flow, or there could be some policy changes that are happening where we are resimulating or we are changing the flow itself, right? So there is some, because that is happening on the same thread that is operating on the bulk sync too. So there could be some locks, right? So, and we want to minimize these locks, right? So we want to kind of rate limit, or we want to control the way we push these flows from one DPU to the other.
Rate limiting
I
is
mean,
one thing.
that's sure, that's fine, right? So, because I think, because I haven't seen the document, right? So because basically I think all I care about is the API between the Sonic and the site, right? So as long as, for example, I think in your SDK you may have thread, you may have logs, you may have other things that you want to decide which flow you want to sync first. Those kind of things. I think that's fine. So what? But the API between the Sonic and Sai is kind of what kind of API that we get, right? So for example, the Sonic still ask for all the flows, right? So then the SDK can determine what flows you want to send, based on your own priorities, your threads, those kind of things. But that is your implementation details, right? So.
Correct. Yeah, right, Gohan. So I think the way Sonic controls to say that start the bulk sync now, pull the flows and push them. And then the messages themselves are all the messages are well-defined messages for the flows themselves. So on this stream, the only thing the DPU controls is how do we push these messages in, these flows in what order. That is all. But it does, I think it is controlled by Sonic. I think when we come to the messages, maybe that will be a little more clear.
Okay. All right.
Yeah. It is still Sonic still controls to say.
Yeah, I just wanted to put one thing and make sure people understand. There are two things going on at the same time. You are doing a bulk sync, and you're also doing your regular data path sync where new connections come in. Those are being sent over in parallel, and they are independent. And that's why you can take a snapshot and just work on that. But the new connections actually just behave as normal. They go through what he's calling the DP sync channel. So there are two things happening at the same time.
That was my question. Is there any race condition that might happen while we are doing the control plane sync and the flows are queued up there and the DP sync channel has the latest and it's already synced that, and then once the bulk sync goes through, will it be, do we have a means to avoid that?
Yes, so there is so this is part of the there is, you're right. So there are two conditions here, right? So one is while we have a snapshot, there might be a new connection that is created, right? So that is the easier one, right? So we know that we look at this color and then we say that, okay, it's a new connection and it is not there in the snapshot. So we just sync it across to the other side, right? And the DP sync carries the flow. We know that the control plane sync is not going to come and interact with that flow at all because that is a completely new flow. Now, so the second one, the second condition, this thing is scenario is we have a flow which is there in the snapshot. It was there, it has the same color, which we are going to sync via the CP sync channel. When we are doing the sync, there is some change that affects the flow, either a network event or it could be a configuration event, right? Something that comes and affects the flow. So now we have to be mindful of where is it. If you have already synced the flow across, right? It is okay for DP sync to go ahead and send an incremental thing. But if that flow has not been synced across, right, then you can hold off on syncing on the DP sync, and the control plane would actually sync over the state when it actually pushes the state across, right?
That would be good, but how do we achieve? Continue.
Yeah. So I think that might be, I think in the what would need in the implementation, what would need to happen. I think these are cases that are there below, what we need to take care of. Effectively, it's a very implementation specific thing, but we actually go mark in the flow what is the state of the sync. So that way, the data path knows whether to. So in the first two cases, the data path can actually go ahead and make the sync across, right? It can do the sync, but in the last case, it needs to hold off. So that happens
So-
by
Maybe sorry to interrupt. I think I have a basic question. I think the document says the CP sync, bulk sync, and DP sync happen in stages. Are they happening in parallel? Or are they happening in stages?
they're actually once the CP during this the bulk sync, the DP sync is also happening in parallel for all the new flows or any new changes.
Oh, so it's not in stages. Then I think
not in
because
stages.
It's not
Yeah.
disabled. Yeah.
It's not disabled. Yeah, it's happening in parallel.
oh, maybe that we need to get clarified because it says in staging, meaning that I thought it was the bulk sync happen first, and when bulk sync finish, and DP sync starts.
No, it's
No,
parallel
nothing's
for
happening.
sure.
No.
Oh, both happen at the same time. Okay.
Right.
Oh, then maybe we need to clarify that.
Right.
We can mention they're happening in parallel somewhere. That would be
Correct.
useful.
Yeah,
Now-
I think I have it
Yeah, I
in the
think that
flows.
is also one of the requirements, right? I mean, one of the documents that we have on our GitHub website about this perfect sync.
Yeah,
that does
That's right.
talk about that this is one thing that we wanted to achieve, and I think this is what it is doing.
correct.
That's
I think I have
correct.
some this thing on. Yeah, I have some this thing on the interaction between bulk sync and data path sync. One section. It kind of talks about what are the.
Otherwise, the reason it's happening in parallel is, and why it's called perfect sync is, you get all kinds of race conditions if you didn't. So this is just an easy way of saying, if I mark everything that's in the table and I send all of that over, while in parallel sending over anything new, any new connection or being created, deleted, altered, or whatever, then I know through the bulk sync that when I'm complete, I send everything. And that's why we call it perfect sync. And I also know that anything new was also sent over. So you're exactly in sync, like right down to the connection. You are 100% complete with just one traverse of the table. You're done. You don't have to worry about the race conditions when you do it this way.
Like, for example, when we have all the flows included in the snapshot for bulk sync, at the same time, there is change in the state of the flow that's in the snapshot, but not yet sent or processed, right? Not sent, suppose. If there's a way to notify the DPU that the DP sync channel to hold off on that one, then we are good.
Right.
Yeah.
You can also just delete it from the table altogether if the notion is I'm going to delete this connection and it was previously in the bulk sync table. I mean, it can be deleted.
Deleted
as
from the
well.
snapshot. Yeah.
Yeah, it can be deleted, and then you won't have to worry about it.
Right. That's the delete case, and yeah, they could be.
So
Yeah.
yeah. Create
One
case
way
is
is-
easy. Delete case, you can delete it from the bulk sync because
Right.
it's the same table you're trying to sync. A re-simulated case may be different, harder.
So there are a couple of different ways to this thing. I think one other way is you could actually mark in the flow. There is some state you maintain in the flow in terms of what is the sync state, right? Whether it's been synced, not synced. Could use that from the DP to handle.
A flag.
Sanjay, one.
Yeah, a flag in
Sorry,
the
sorry.
flow
Okay.
itself.
Hey, Sanjay, one question. In terms of partitioning of work, right? Like, so I expect there will be like a HA Sonic module, which is the one actually streaming this connections, the flow state, and it goes via the SAI APIs to stream the flows from the DPU and streams it across to the paired DPU, right? Like, so question is like, I assume there is no state that is maintained within this Sonic HA module for each of these flow states, correct?
Not
Like it's
for
all
the-
within the DPU.
Correct. Correct. Not for each of the flows. There is some state in the Sonic thing, which is the state machine and things like that, but nothing for per flow, nothing for the flow itself.
Sure. All that
Yeah.
is maintained within the DPU itself.
Within
right?
the DPU itself. Yeah.
Sure. Thanks.
This is just I think in this thing the Sonic here is just relaying the in effect, right? Relaying between the DPUs through the control plane channel, but it is there's no state maintained in the Sonic.
Sure. Thanks.
Then we have the data path synchronization itself. I think in this proposal we follow the inline replication that Balki explained in the last meeting, in the couple of meetings back. So in this, I think effectively the two DPUs are treated as one DPU. I mean, as one logical unit, right? And whenever there is a flow inserted, we make sure that the peer also inserts the flow before it gets forwarded to the other side, right? And yeah, so right. And so when we are syncing it to the other side, the primary DPU is the one that I'll change. I think the DSC is DPU. I think DSC is our Pensando terminology. So the primary DPU kind of evaluates all the policies and then inserts the flow in the secondary. And whatever was the policy results from the primary is honored on the secondary. I think this flow insert happens with exactly the same. There's no difference between the two. So the reason I think this is critical is because we can never guarantee that the primary and the DSC will be at exactly the same configuration level at any given point in time. There might be differences between the two where the controller has pushed some new config to one of the DPUs, but not the other yet, right? Or we haven't applied on both the DPUs at exactly the same time. So it's critical that we have some source of truth, and the source of truth for policy is whatever is the primary DPU in this case. Okay. And then on switchover, there is a reconciliation or the flow resimulation that we've been talking about. That kind of updates to whatever is the config level on the secondary. It kind of updates the flows and it gets it back to that level on the secondary. But during the sync, it is always the policy results from the primary DPU that stays, that is honored on the secondary. In this mechanism, whatever is the control packet we get, effectively, I think this shows to this thing. We have an outer header, which is the primary CNIP and the secondary CNIP. There is a UDP. It goes to the UDP packet.
I have a question here, right? So I understand the policy not syncing between the primary and the secondary, but why we are considering the flow resimulation case during the sync?
No, not during the sync. This is on switchover. Go on. Sorry, I didn't mean during the sync. On switchover,
it can happen during the sync too, isn't it?
Sorry, what's that?
Sorry, the resimulation can happen anytime, right? During
why? No. Why that becomes a requirement? Resimulation. My understanding is triggered by us, right? So why we can block the resimulation? Why we need to do the resimulation during the sync? I mean, why adding that extra requirement to the sync?
I was under the assumption that the resimulation happens quite often, and then the sync has to continuously take care of that change.
No, but this sync, at most, I think is on the order of, minutes or maybe tens of minutes, right? So why is that? I guess, okay, so I think Pensando clarified that there is no resimulation during the sync. It's only the resimulation during the switchover. Is that right? Or
yeah, the reconciliation we're talking about here is during the switchover. So we have honored whatever is the prime. or whatever the resimulation. So the resimulation, we have flows on the secondary DPU now. There is a switchover, and the flows on the secondary DPU, the state may not match whatever is the policy state that is there on the secondary. So we wait for the controller to trigger the resimulation, and then we bring resimulate the flow.
Okay. Oh, I see. Okay, that makes sense. Yeah. Okay.
Can you explain
what you mean by
that doesn't
policy?
make sense.
Can you explain what you mean by policy? Is it just the ACL result? Is it the route lookup? Is it the mapping? Is it everything? Like what do you?
It's all the layers. You could have it change. Resimulation is to fix all the layers. You can come down and change the transformation of a policy. You can change the rules. They're not ACL. They're called rules. You can change any of the rules, right? And any of the transformations. So it's all of it. But that's resimulation can happen after the fact. I mean, it can just be initiated, and it can happen per normal resimulation rules. It has nothing to do with HA really. It's just something that after you do an HA, it's obviously a good thing to do a resimulation, but it's independent of the HA.
Yeah. So basically, what I'm hearing is that, before you first do the sync, right? So then before you do the switchover, actually the control plane is doing the switchover. Right before that, you switch to the second DSC. Then at that moment, the second DSC is getting all the up-to-date policy and do the resimulation on the second DSC, right? So that's what you're talking about.
Correct. Yeah.
Yeah, but it can do it at its leisure. It doesn't need to do it like as part of HA. You can do it once you do the switchover. You can do that. I mean, they're never perfectly in sync. That's why you do resimulations.
Yeah. Okay. I mean, that makes sense, right? So, it's not really related to the HA. You just that before I, make the stand up to be the active, that moment that I want to do a resimulation.
And I think you should have an API
so
to that, but you could choose to do that, or you could choose not to do that and let the unit.
Of course. Yeah.
But we should check the APIs to make sure that we have that to make sure that we can force a resync.
So why are we making this? Why are we making this one as requirement as part of this one, right? I mean, one thing we are saying that secondary DPU does not get the policy, right? The policies changes or policy itself. Forget about the changes, right? The policy dump only happens after the switchover to the secondary, and at that particular moment. So the question here is that during the course
of
the.
That's not true. They both have the policy. If you're a backup, you have the policy. You both have the same policies. And it's just that they may be out of sync because software can't update them both simultaneously. There's no multicast here. So they could be slightly out of sync at any period of time. And that's why we do resimulations. But you don't need to do it as part of HA, you don't need to do it. It's just highly advisable to do it after HA is done or before you do the actual switchover, but it's independent.
Okay. So that actually clarifies. So thanks, Gerald. So the question I have here is
they both always have the same policy for sure. If you're a backup, you have all the policy.
So then the question here is that, when the policy changes happen, they are reflected on both the DPUs. And so then the question here is that do both DPUs run their flow resimulation independently? Or is the primary runs the resimulation and the changes are actually synced across to the secondary afterwards? How does actually that work?
It is always the primary's policy.
So it's the primary's policy. The primary is going to run it, although the changes are reflected in both of them. Since the secondary knows that, it is a secondary, it is not going to run the flow resimulation. Primary is going to run it. And if there are any changes that amounts to it, that the changes are synchronized through a control plane channel to the secondary. And then that ensures that, both of them are in sync. So I just, for the sake of this discussion that is basically going on is only about that time period where basically there is switchover in which
Right.
if the policy were to change, how do we really take care of them, right?
Correct. That's my
Okay.
So you force trigger a resimulation after that.
Why
Is
force? I mean, if there is,
resimulation?
The thing is that it's independent because the DPUs know that they've received new policies. So you could be doing a bulk sync and the data path sync, and the DPU is still getting policy updates from SDN somewhere because they're asynchronous. They don't necessarily know what's going on.
Mm-hmm.
And so they can decide to do a resimulation at any time. If they receive
Anytime.
new policy, they'll do a resimulation.
So
That sounds
then,
correct.
for
That
the
sounds.
for the unplanned failover, is that after the failover, the newly active DPU initiate resimulation, or that knowledge is known as the controller and controller initiate that?
Yeah, so after the switchover, what happens is basically the controller will trigger a API to do the resimulation. The reason being that after the switchover, if you let the new whatever the standalone, right, to do resimulation immediately, there is no guarantee that the policy that it has is current with respect to what it was in the primary. So it is the controller that will come and invoke an API to say from now on you can start resimulating the flows, because this particular node has caught up to the previous primary with respect to configuration.
It's not automatically done.
So that means there will be a notification, right, from the newly active back to the controller indicate it's ready for resimulation.
Not notification. See, after switchover, the unplanned switchover, after that, the controller basically sees that there is a switchover event, and then it will invoke the API to start the resimulation.
Okay, resimulation at that point is to check, make sure that the current policy is applied once again to all the flows, active flows that it manages.
Correct. That is to make sure that I think the trigger come from the controller indicates to the DPU that the policy levels are synchronized. It's at the latest, and then we can actually go and apply this.
Okay. Yeah, the DPU, once it comes from standby to active, once it's done with some init tasks, it has to inform the controller that it's ready, or it can, once if the RX channel is already open and it can get the command from the controller, then it can queue it and do the resimulation also. That's true. It probably doesn't need the that the DPU is ready signal to the controller then.
Hey,
Christina,
one question.
you're probably on mute, Christina. They're saying something.
Sorry. Doesn't the advertisement from the failed DPU just stop? And so that becomes not available. The new one becomes available and says, hey, I'm the best path and I'm ready.
Yeah, so I think from a network perspective, the traffic is still, on switchover without any of the control plane, whatever the messages that we're talking about, without any intervention there. The network will actually start forwarding traffic to the secondary, and we will continue to forward for any traffic for any of the flows according to whatever the state was synced, right?
Yeah.
Now the flow resimulation kind of updates again.
Yeah. Now I hate to be a PM here. I have to do a time check. Do you guys want to keep going, or do you want to cover the rest of this in a second session next week? Gerald, John, Gohan.
I think you need to do it in a second session because there's too much more
this
to
is
go
a
through.
lot. Yeah.
But if this is if this has already been submitted, people can also read it.
Sure. So we were thinking do a PR to submit after this conversation. Would that be okay with the AMD team?
Sure, Christian, we'll do.
Okay. All right.
So one thing I could comment is that maybe it would be better to get to Markdown so that we can easier comment on the document. But I might find if you get the PDF out first,
yeah,
and then I think, you know,
Markdown.
yeah, so there are some details that we can look and people can, community can look and then
Yeah.
and then read more in details.
How long will
I
that take us to get the Markdown, Christina?
I
Do
can
we even have
convert it,
anybody to
or
help?
AMD can do it. I mean, whoever wants to
I
do
can
it.
try. I can try
Okay.
converting.
All
I
right.
can try converting it.
Okay, and if you can't, if you need help, let me know.
Sure.
Okay.
Yeah.
So guys, I guess we're gonna call it since it's 12:03 and pick it up next week. Is that what I'm hearing?
Yeah.
Yes.
Yeah. Okay. Thank you so much, Sanjay and Balki and everyone, Vijay, Han. I'm gonna stop the recording and post it, of course, and then we'll move this to Markdown and pick it up next week.
Thank you.
Okay, everybody,
Good. Thank you.
thank you for your time.
Thank you.
I appreciate, yeah.